So I will start. So we'll talk about Rudder security and our strategy to ensure security of the product. So I'll just introduce myself. So I'm Alexis Mousset. I have a sysadmin background, but I am now a developer, more specifically system developer at Rudder, working on the agent configuration policies and security topics. And I'm also, outside of it, part of the Secure Code working group of the Rust programming language. So today we'll talk about a broad range of topics regarding the product security. So we'll talk a bit about Rudder features for security and how we changed Rudder in recent years to improve the security. We'll talk about our vulnerability handling process. We'll talk a bit about software supply chain security, and we'll end with dev team culture and processes. So we'll try to cover the whole range. So I'll start with Rudder security itself. So what did we do inside Rudder to improve the security of for our users? So the first thing is that we now integrate security topics into the roadmap and the roadmap process. So we have a dedicated security roadmap, and we integrate elements based on priority in this roadmap into the general product roadmap. So before this year, it was more or less an ad hoc process, but now it's more structured, and we really integrate the security improvements directly into the roadmap. So the thing that changed most in recent years is the node server communication security, because that was one of the weak points before that. So we now ensure we have TLS 1.2 at least for all communications occurring on the network. For people who have used Rudder in the past years, it will probably match what you knew. For the others, then well, that's a change from before. We had actually two network communication protocols, and until last year they were using different credentials, so different certificates. So it was a bit hard to maintain, and it by default one of the protocols did not verify certificates, and it required user configuration, which some did not do. So now we have a unique key and certificate for both protocols, we verify certificates everywhere. We also improved the HTTP configuration to allow splitting the node server communication and the communication between the Rudder server and the users through the web interface or the API, so that people can apply different security rules over these two network flows. And also they can change the port used by one of the protocols to have specific firewall rules, allowing better segmentation of the network and avoiding, for example, people outside accessing the API dedicated to communicate between nodes and server. Another area which evolved was the user authentication. One of the mistakes that was done in the past was that when you install the Rudder server, it would create a default user with the admin password. So that's the classic mistake, and what happened is that a lot of users actually let this user and just added new ones, and so that was a really bad idea. So it's not the case anymore, and we actually deleted the admin user with admin password on upgrade at some point, because we wanted to be sure that it has disappeared completely. We also improved the storage of local passwords, and we now added support for OpenID Connect, which allows two-factor authentication for the web UI, and integration with a centralized user identity management with what the company or the organization uses. We also worked on a more infrastructure level to harden our services configuration. So for the new RelayD service and our existing slapd service, we have added, so we have a dedicated system user. We have SELinux policies on Rail to contain these processes and only allow them to do what they need to do. And we also added some systemd-based hardening rules. Systemd gives access to some easy-to-use hardening policies, like the protect system, which allows marking the system as read-only and only allowing a specific set of directories to be written. And it's done through kernel namespaces. So it basically mounts the system with a read-only permission and only remounts some specific directories with a write permission. So this reduces the attack surface, and also a private temporary directory, for example, for each service. This was in version 6. Version 7, we also improved our compilation flags for the C dependencies that we embed with the basically state-of-the-art options. Maybe in the future we'll switch to 45 source 3, which was released recently, but for now that's what we use on compatible systems. And the latest changes that we made were on the front-end side, so what happens in the browser, and we focused on this this year for the latest release 7.3. So we improved the session exploration process and backported this to 7.2. We also did some hardening configuration against classic cross-site scripting and CSRF attacks. We were not totally up to date with the state of the art. So we improved this, and we also now improve the way we manage our JavaScript dependencies. I'll talk a bit about it later. And we have Nexcept already identified. So we have some JavaScript. We use the AngularJS 1 JavaScript framework, which has reached end of life and it's not maintained anymore. So we have a few applications to replace. We want to add a built-in two-factor authentication. Now we have it through OpenID Connect, but we also want to have a built-in mechanism for this, maybe through WebAuthn, which can be used with the YubiKeys or TOTP for a classic system. We have a few services still running as root, and we might switch them to a dedicated user. And we probably have everything we need to switch to TLS 1.3 everywhere. So that's probably something that will happen in the next months. So that was for for Rudder itself, just for what happens in the last 2 years approximately. Now we'll talk about more higher level stuff, basically. So something outside of Rudder, but more in the way we develop it. So I'll start with the vulnerability handling. Before, until 2 years ago, we had ad hoc process to handle vulnerabilities. So when we got a report of a vulnerability found in Rudder, we would try to fix it and warn the customers, but it didn't follow any specific process, so we ended up missing some steps usually. So now we have a well-defined process with a centralized reporting point with an email address. We maintain an internal database of reported vulnerabilities, which allows us to keep track of internal information before disclosure, with all actions taken about this. And we may embargo some tickets with private tickets in our ticketing system in case of serious vulnerabilities that we want to keep private until the release is made. And we now also have a communication process where we will usually notify our customers in advance, maybe give some workarounds, and then community notice and release at the same time. So this is the state of the internal database of our known vulnerabilities. And now I will talk about the supply chain security, which is an important topic, and we'll see how we handle it. So what does that mean? Well, the software we build is built from sources that we write. We developer write code, but that's not directly what the users use. So we will push this to a repository, and then we have a build process that will download our code plus dependencies. It will build it, and it will put it on a server accessible by users, and then users will download the software. And so we've seen the vulnerabilities in Rudder itself, in the code we write, but there can also be vulnerabilities somewhere else in this process, especially in the dependencies or the build system. And that's also something we need to address as software editors. So there are basically two main risks regarding the software supply chain. There could be targeted attacks against an editor to target the users behind it, or there can be vulnerabilities, bugs, but deep inside the dependencies tree, and that it may be hard to keep track of them and fix them. So we have two great recent examples. So the SolarWinds attack was actually targeting a monitoring software supplier, and they infected the build system, and basically were able to deploy infected software through the usual update channel by infecting some of the build servers. So that's one of the threats we have. The other example is Log4Shell. So a vulnerability in Log4j, a Java library used for logging, which was really used by a lot of Java programs. And it revealed how difficult it was for companies, organizations, to know where they actually had Log4j and in which version. And it took a lot of time and a lot of work, and it's basically not over. There are still vulnerable Log4j in the nature everywhere, and this really showed that there is a lack of visibility over the software we use, and hence a lack of ability to upgrade it when there are vulnerabilities in it. So yeah, this was really present in recent years, but it will very likely continue to increase because this is basically not a solved problem. So Rudder is a critical component with a lot of dependencies. It's quite complex software. It talks on the network. It exposes rich interfaces. So this makes it basically a good target, like all other infra management software. So we need to manage our dependencies in the best way we can. We need to apply the good practices regarding security. And we need to especially focus on the build process and the deployment process of our software to ensure it's as secure as possible. And we also need to provide more information to our users. It could be specialized documentation. It could be the list of components that we include in the software because they needed to handle their own security. I just mentioned that I will give a talk dedicated to software supply chain security tomorrow at 2 p.m. in the security room with a lot more details about this topic. I'll just do it quickly with a very practical point of view, but in the other talk I will give you more information about the background. Dependencies. We actually have a lot of dependencies, and we especially have a lot of software ecosystems. We have some classic C dependencies like OpenSSL or curl or CF Engine, but we also have programs in different programming languages, in other programming languages, which include Scala Java programs. We have some Rust for system stuff. We have some F# on Windows. We have some Elm and JavaScript for the front end. And we have some Python and Perl for some glue and other dependencies. So that makes a lot of different ecosystems, and it makes it hard to keep track of everything. So what we do, starting from 7.0, we decided to set a process of upgrading everything to the latest version, basically every 6 months, because we do a minor version every 6 months. And we decided that we want to ensure that we are at the latest version of everything every 6 months. Because before that, we had, it's not that we never upgraded anything. We upgraded the dependencies regularly, but some of them lagged behind. And in some cases, it was hard to upgrade when we figured out there was a vulnerability in something not upgraded for 3 years. And so that was a problem. So we now upgrade everything every 6 months. This allows reacting faster to security problems, because that means that we usually use a branch or a version that is still maintained, so we can get patch releases with security fixes more likely. We have a few exceptions, but they now need to be documented and explained, and we need to have a plan to actually upgrade the dependencies. Yeah, that's our new policy. And we especially focused recently on the front-end code, because it was the worst at the moment, because the JavaScript especially we tended to have old JavaScript libraries around, so we centralized everything and managed with npm to ensure everything stays up to date. Because we lacked a package manager before, and we made basically manual upgrades by copying the JavaScript from the source, and this just doesn't work. Another important thing, now that we keep things mostly up to date, is to monitor for known vulnerabilities. So we need to keep track of vulnerabilities affecting either one of our dependencies or the build system. So we started actually monitoring for known vulnerabilities 3 years ago. And it incrementally extended to all the components we use, and it's now pretty complete. So what does that mean? That means that for some stuff we need to have more or less manual check through mailing lists or other standard channels for vulnerabilities, especially C components, which usually, well, there's no package manager, there's no vulnerability database except for CVEs, so we need to do it more or less manually. But for programming languages that have a package manager, there is usually a way to keep track of the known vulnerabilities, and that's what we do whenever possible. So we have automated checks that run daily, and we'll scan all the dependencies across all ecosystems to check for known vulnerabilities. And when we have an alert, we will have several responses depending on the cases. Sometimes we'll just ignore it because we're not affected, and it's actually maybe half of the time, because there are a lot of false positives with these systems. That's one of the problems. We sometimes just upgrade the dependency, and in some cases it may be a serious vulnerability, and in this case it will be treated as such. And for example, we had a serious vulnerability in a Java library doing the authentication for local accounts, with a vulnerability on the bcrypt check, which was treated as a serious Rudder vulnerability, and was actually detected by this tooling just a few weeks after we set it up, so that was good timing. Okay, so there are dedicated tools for almost all ecosystems, but this needs a bit of plumbing to be integrated to the alert system across all the ecosystems. So this took a bit of work on our CI platforms. Do we have a software bill of materials? So are we able to provide a list of all included components in Rudder to our customers? The answer is not yet, but we're getting there. We mostly have the required pieces because we are able to list the components, but not in a structured software bill of materials way. There are a few tricky points. For example, the fact that we provide plugins. So it's hard to give a general, we would need a list for each plugin. So that would make the whole thing a bit harder. And in general, the software bill of materials ecosystem is quite immature. And I'll talk about this in tomorrow's talk too, but this makes it hard for now to just aggregate everything in a standardized format. So for now, it's mostly we have a list in some form for each ecosystem, but we don't have the aggregated view across all programming languages and all dependencies. But it will probably come in the coming months because the tooling is getting better really quick. We also worked on the infrastructure side. We mostly switched to ephemeral container builds, which was previously done in VMs, which were not really ephemeral. We also have a dedicated signature server. So the signature is not done either on the build system nor on the distribution system. It's done in between on a dedicated server that has very restricted access in order to protect the signing keys. And we improved the credential management in our CI platform with the proper passwords handling and key protection and this kind of stuff. A little note about the security monitoring. We actually need it for all our dependencies, but we also need it for the build infrastructure and tooling. If you use a tool to build your software, then you need to check regularly if it contains vulnerabilities and fix them. So the need for vulnerability check extends to the whole build system actually, because it can be a vulnerability too. We improved the documentation to focus on best practices and provide hardening documentation for our users, because some of the changes that would improve security are not possible on all cases. So in this case, we need the documentation. And I'll finish with the developer team culture and how we worked on it. So Rudder didn't have a very strong security culture before, let's say, 3 or 4 years ago. And so we tried to improve it and to raise awareness around security topics throughout the team, especially for people not close to the business, like front-end people and back-end people sometimes who are working on working on the code and are not always very aware of the context where it's used and the business around it. And so we did internal trainings. We did 2 this year for general code security best practices and one more focused on front-end topics. And we also have, for a few years, a systematic security assessment of all changes and features in the architecture documentation. We are now, so when someone proposes a feature, they have to detail the security implications and what the effects could be. And that's the end of the presentation. Do you have questions? Yeah?
How do you manage trust between Rudder and the agents?
The default mechanism is trust on first use. So basically, when you install an agent, you would just set the hostname or IP of the server it should be managed by, and the node will connect a first time with the server, and then it will store basically the certificate fingerprint, and then it will check at every connection that it stays the same. And the same is true also from the server point of view, which will register the certificate when it's first connected and then check it in future communications. But it's also possible to pre-provision this trust, so you can preset certificate hashes on the agent when you deploy it, So it will only talk to its server and not another rogue server. Or
so the agents are self-updating, or do you need to do it manually if you need to update them to a newer version?
For the agents,
yep.
They are not self-updating, but they can update themselves like any other program on the system. So you can deploy a policy to update the agent like any other system or like any other program on the system. And the agent is capable of self-upgrading, but it's not like automatic or anything. The users need to configure a policy for this. Yeah.
I just want to say thank you for the work. In 2015, I think, I gave this talk about config management security, and there was almost no feedback, but one vendor came to me afterwards in a break and silently said, yeah, we also worry about this stuff, if I could tell it more, if I already have survey results. And I asked him which company he works for, and he wouldn't say, and he left. And you're standing here now and giving a public talk about all the work you did, and that's really great. Thank you.
Okay, thank you.